Just like how a probability conveys insightful information about your data, so does expectation. When you hear the term expectation, that's just a fancy, very technical way of saying average in statistics. Let's dive into expectation. Here's the formula of expectation. It's e to the x, which is equal to the sum of I equals 1 to n xi divided by n. Now let's break this down. The e in this case just indicates expectation. It's a mathematical notation of expectation. The x here is the random variable, so the variable of interest. The summation here can be somewhat tricky. The summation, what this basically means is that when you have a set of data points, you're essentially taking the sum of every values in that data. So for instance, if you have a data set that is x equals 2, 3, and 5, you're just taking the sum of these values. So 2 plus 3 plus 5, that is 10. And so the sum of xi is equal to 10. Now, what is I equals 1 and n? Well, those just represent your index. Those just represent your indices. What this basically means is the index of the data points that you're going to take the sum of. So I equals 1 is 2 in this case. I equals 2 is the second data point of your data set, so it's 3. And the last one is I equals 3. But going back to the summation, what is n? Well, n is your sample size. So going back to this example of your data set has how many values? It has 3 values. So the sample size is 3. So you can see that your sample size gives you the last index of your data. I equals 1 to 3. Xi, that's equal to x1 plus x2 plus x3. And so that's equal to 2 plus 3 plus 5, which is once again equal to 10. Now let's go back to the expectation. The expectation, like I mentioned earlier, is just average. What you're just doing is you're taking the sum of all the values in your data and you're dividing it by the number of elements or sample size. And so the sample size is n, and the xi represents each of the value of your data. Let's dive into an example. Suppose that you love to bake cookies and your friend loves to steal cookies from you. You have a set of data points with each data point representing how many cookies your friend has stolen from your cookie jar. Now I'm going to express this as x, and the data is, so the first week your friend stole 2 cookies, the second week your friend stole 3 cookies, and then 4 cookies, 2 cookies, and last week your friend stole 2 cookies. So we have total 5 data points. N equals 5. Now let's set up the expectation here. So e to the x equals the sum of I equals 1, and remember, the top of the sum, the n in this case, is the sample size. The sample size of our data point is 5. Xi divided by, and once again, we have n, the sample size, so it's xi divided by 5. Let's expand this form. The sum here equals x1 divided by 5 plus x2 divided by 5 plus x3 divided by 5 plus x4 divided by 5 plus x5 divided by 5. So just right off the bat, you can see that writing 5 multiple times can be very redundant. So with mathematics, there's a shortcut. If you have two values, 2 divided by 5 plus 3 divided by 5, this is essentially the same thing as 1 divided by 5 times 2 plus 3. If you're not convinced, let me show you real quick. 2 divided by 5 plus 3 divided by 5, that's 5 divided by 5, which is equal to 1. 2 plus 3 divided by 5, well, what's 2 plus 3? That's 5. And dividing that by 5 is 5, which is equal to 1. Taking out 5, the technical terminology is actually called factoring out 5. When you factor out 5, that gives you the same result had you left the 5 as it is. So we're going to use this factoring technique, and when we do that, we can take out the 5, so it's 1 divided by 5 times x1 plus, now there's another shortcut, and that's just plus dot dot dot. That just basically means all the values in between x1 to the last value, so x1 plus dot 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 plus x5. And you can also write this as x1 plus dot 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 plus x5 divided by 5. It's purely up to you. I like to use this form for expectation typically. So with the cookie example, the values are 2, 3, 4, 2, and 2. And we want to find the expectation of this. And so we're going to replace the x1 plus dot 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 to x5 with the real values that we're calculating here. And so it's 2 plus 3 plus 4 plus 2 plus 2 divided by 5, and that's equal to 13 divided by 5, which is equal to 2.6. Just to recap, the formal terminology of average in statistics is expectation. And the expectation has the following formula. It's a sum of I equals 1 to the nth index, xi divided by n, and that is equal to x1 plus x2 plus dot 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 plus xn, and the dot 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 representing all the values in between x2 to xn, divided by n, and n in this case is your sample size of the number of data points in your data. And the mathematical notation of expectation of your data is e to the x being the variable of interest in this case.